Recording is on.
Okay. So do we normally do an intro?
Yeah,
No. Okay. All right. So this is Polished Ruby Programming, Chapter 9, Meta Programming and When to Use It. And yeah, I guess we should just go ahead and dive in here. I usually kind of like to scroll through here and let people mention or interrupt. And then I stop at the boundaries to give people an opportunity to chime in. So I'll probably just go ahead and do that. These are the topics we're going to cover. Pros and cons of abstraction, eliminating redundancy, different ways of metaprogramming methods, and using method missing. So pros and cons of abstraction. So here I remember the author is, he's saying that technically you could view this as metaprogramming, but that's not really what we're talking about when we are metaprogramming. And he gives this example here where we actually do not know the name of the class or the methods when we're actually writing the code in here. Now, I took a note that was an interesting approach to defining metaprogramming. I'd actually never thought of it that way before. But now that I think of it that way, this is often, if not always, true of the code that I'm writing when I'm actually metaprogramming. So I just took a note that was an interesting kind of way to describe what it is. So I'll keep scrolling along here. Okay, so here he gives an example of some metaprogramming that, and I guess this is subjective, but I think most programmers are going to agree that the example he gives here with metastruct is not a helpful form of metaprogramming. So here, the idea is whenever you call a method on class A, the object class A, it's going to define a method on class A, which he shows here with method missing. So if you call a method on class A that does not yet exist, we are going to define that method. And so instances of A will then get access to that. So B just defines a method that does nothing. Foo defines a method that returns 1, which he's demonstrating here. And then here he's demonstrating using a proc or using like a block or a proc here. I took an interesting note that I also say dry up as a verb. And I didn't know if other people did that as well. So seeing in the book, I'm guessing maybe a lot of people say, I see dry all the time in conversations about code, but the concept of drying up code as a verb, I didn't know that was so widespread, which maybe it is since I see the author using that terminology here.
I've heard it before, yeah.
Yeah, so I think it must be widespread.
But now that I think about it, I've never heard the term wetting up code, so...
So here he mentions, but at what cost? And then here he's describing some of the problems with the code here, which kind of just revolves around if the user of this code kind of makes a mistake or whatever, they get sort of surprising, unexpected behavior. And he's using this as a demonstration of a bad abstraction. And then here he's trying to give an example of what would be an example of a good abstraction. Again, it's subjective, but I think it kind of makes sense, the examples that the author is giving here. Here he gives an example of a module that can be used to automatically memorize methods of an object, even if the class of that object wasn't designed with memoization in mind. I do think it's still a double-edged sword when you're doing that, but he's demonstrating this as a useful example. So I think it does make sense. I guess the real lesson here, which I think we all already do understand, is that metaprogramming is a double-edged sword, and I believe the author might even start off with that phrase. Well, I don't see it, but it is in here somewhere, I think. Well, I think that he gives the double-edged sword.
On the very first of the chapter.
Okay, yeah. And I think I'm assuming that the three of us have written enough Ruby code with and without metaprogramming that we already know it's a double-edged sword, or if not, at least we've heard. This is probably not the first time we're hearing that it's a double-edged sword. So that is the real lesson here. I think of this first section. So I'll just stop there in case anybody had any thoughts to add or any questions. I'm going to check my notes too.
I think I'm good.
Okay.
I mean, so maybe we should be clear about the examples. Like the in the first example, the reason it was bad is because now you have situations where where you can uh, write a typo and the language no longer provides that safety net for you of like,
Right.
oh no, this method doesn't exist, which is something surprising that you wouldn't expect, and it's a trap that you don't see and you can easily fall into. Whereas the second example, the reason it's good is because you have to actively use it, and in actively using it, like you have to say, okay, I'm gonna like choose to memoize something, and so I'm gonna write memoize, colon bar or whatever. And
Mhm.
because you are doing that, you are buying into all the um, all everything that comes with it, and so like it's not so much you have to know about it, and you actually have to write some code to get it to do the right thing, and it's not as surprising because you're you're an active agent in using it.
Yeah, that's a good point. And that code is here where here's the explicit opt-in that. So yeah, that's a good point actually. We have an explicit opt-in here, whereas in the other one, it's just it's built in using. I think method missing right here. One thing that, and again, this doesn't really matter because it's sort of a stylistic thing or whatever. I actually tend to not reopen a class in this way to do this sort of thing. I think I'm a little more inclined in my code to just do a.extend and then a.memoize if I'm already outside of the class, but that doesn't matter either way. Cool. All right, so I think I'll continue along here. So he points out one of the best reasons to use metaprogramming is to eliminate redundancy. And let's see. Oh, this is fun. There's something in here that, yeah, he mentions unless they are getting paid by the line. What's funny is that even if I'm getting paid by the line, I still would probably want to eliminate redundancy just to make, well, at least in certain cases, just to make it more enjoyable to write the code. But yeah, that was kind of funny. So this is kind of a good, I feel like attribute accessor could have been used maybe as a good example of metaprogramming that the reader would already be familiar with and showing how it eliminates redundancy. So we have some code that's introducing two quote unquote attributes to a class that are not leveraging attribute accessor. And then here we have code that is using attribute accessor. Attribute accessor will set up these methods for you. And, that's kind of what makes it metaprogramming to me. And you can see that it eliminates the redundancy. So that's interesting. And I took a note on that. I also took a note that I think to some extent the rise of Ruby's popularity actually played a role. Like I think eliminating redundancy actually kind of played a role in this. At the time, a lot of people were writing code in C# and Java that not only looked like this, but you'd have this redundancy at multiple layers of the app and in the configuration. So what we're kind of expressing here, and you could almost argue that the pendulum swung too far in the other direction, but people were writing code that was 4 times more redundant than this, and then Ruby came along, popularized by Rails, and people started replacing, you know, not only this redundancy, but this redundancy plus this redundancy in 3 other places with something like this. And so it was like, it's kind of the right language at the right time in that regard, or at least that's sort of how I view it.
With the adder accessor, when I first started using the Ruby language, I thought adder accessor was a keyword and part of the syntax of the Ruby language. And it was a complete surprise to me to learn that no, it's a method, the name of a method, and you're providing it 2 arguments to that method, and you can do that inside of a class because when the interpreter reads or parses the this the text in your file, it's going to automatically call that method for you at the time that this class is defined. Foo. That and so that is like the for me, like I didn't realize that was metaprogramming, but it is because this happens at runtime at the time that foo is being defined.
Yeah. Yeah, that is interesting. I just heard a noise. I'm not sure how to access it, so let me go see. Just in case Samuel said something. Oh no, I think it was in Discord. All right. I'll go ahead and stay over here. So actually, let me check. I'm going to check the Discord just to see. No, okay. It wasn't Discord. I don't know what it was. Anyway, come back over here. Oh, I did take a note here, by the way, that there have been times where I've reintroduced redundancy. So there's been times where I've eliminated. I'm still hearing the beep. That's not this chat, is it? Let me see. Oops, shoot, I accidentally stopped screen sharing. My bad. Can you guys see my screen again? No.
Not right now, no.
Okay, sorry about that.
No.
Yeah, sorry about that. I'm hearing, maybe it's up from maybe it's coming from my phone. I'm not sure. Sorry, I was hearing what sounded like someone maybe adding to the conversation in the chat, but they're not. Okay, so what I was saying was there's actually been a few times where I've introduced metaprogramming, and maybe it was the wrong decision at the time, and then removed it because the IDE actually, most IDEs can understand what this is actually going to do and leverage it in a meaningful way. Whereas when you come up with your own metaprogramming, sometimes you lose some niceties of the IDE because you're like magically creating stuff at runtime that the IDE can't leverage at, writing the code time. So the IDE actually has to like know about this construct, which is just kind of interesting. So there's actually been times where I have had legitimate redundancy, removed it with metaprogramming, and then decided for one reason or another that actually life was easier with the redundancy, and I'll like actually bring the redundancy back and remove the metaprogramming. So again, just sort of double-edged sword stuff that I took a note of. Cool. Okay. So now the author is going to give an example of. Let's see here. We are initializing. He has a foo struct here that he's initializing with some data. So we're basically passing in some attributes, which he's storing in a instance variable called values, and then providing attribute readers and writers without using metaprogramming. And then here we are using define method to set up that metaprogramming. And I'm assuming this is another case of demonstrating a more tasteful use of metaprogramming. Okay, so now he's talking about relocating the behavior into a reusable module that can be dropped into any class. And then here we see the explicit opt-in that we saw in the first example that Nelson called out, and then showing that it works. Okay, so interestingly, here we are now setting the options instance variable on a class, and of course, classes are also objects. The author is now he's showing that you cannot go this route to pull it off. You instead have to go this route. So, and I tend to do this with the class less than self approach, but this approach is also perfectly valid. We are going to extend the singleton class of bar instead of extending bar, because the way the module is written, extending bar here influences the instances. I tend to try to use include when that's the case instead of extend, but that's not really important at the moment. What the author is showing here is that we need to extend the singleton class. So we, instead of putting it in bar, which is the class of the instances of bar, we need to put it in the singleton class, which is the class of bar itself. And then we're doing the opt-in on that singleton class instead. And he's showing that it works. He's pointing this out, which is something I've actually thought of too, which is kind of interesting. But here, when we're extending the singleton class, that is just sugar for including in the singleton class of the target. So it's the same ultimately as this. So we're inserting a module into the inheritance tree of the singleton class of the singleton class, just because we're operating on the singleton class, and extend is sugar around including into the singleton class of the receiver. So that's kind of an interesting thing that actually gets kind of weird. I really like object-oriented programming, but I sometimes see people argue that it's confusing. And I think if you were going to try to make an argument that it's confusing, and this is specific to Ruby, so this is not a general criticism of object-oriented programming, I would find that, in particular to a new Ruby user, this would be mighty confusing. So that's kind of interesting to see. We're at the bottom of the section, so I'll stop there.
Yeah, I mean, you have to really deeply understand that what a singleton class is, and the implications of including versus extending, and all this other stuff that in other languages you don't have to know about, and you have more simpler constructs, and it does take a lot more code to express the same thing, but uh, it's very, very explicit, and it does not have this implicit knowledge embedded into it, which this line of code does. It's
Yeah.
Yeah.
Yeah. And to that extent, I guess another thing I would add is that when you are just writing normal application code, you definitely can operate with a much simpler mental model, and you can get away with not knowing this stuff. So at least there's that you don't have to go this deep to write most Ruby code, but it is nice. I really love that it's there when you do need it. But yeah, cool. I think I'll continue along here unless someone chimes in. So here he mentions there's two separate approaches to metaprogramming in Ruby. I actually thought where he was going with this was going to be what he mentions as block-based metaprogramming, which is what has been done so far in the chapter, with the exception of that one method missing. But because we saw that one method missing call, I actually thought the author was going for block-based versus method missing. And I like took a note, I think, that I was going to mention, what about evaluating strings, which is generally a bad idea. So I thought that the author was going to overlook that one, but it turns out where this chapter is going is actually, we're talking about two different ways of metaprogramming methods, which is evaluating strings of Ruby code and the block-based metaprogramming that we've already talked about. And he mentions a few other approaches besides define method, which is class.new, module.new, and define singleton method. I usually don't use define singleton method. I usually do the class less than self, and then just define method. So different ways to skin this cat for sure. So he gives an example here of doing some block-based programming. I'm not going to go into the details here unless it's desirable. This looks like the kind of thing that would be a bad idea in metaprogramming, generally speaking. redefining a kernel method to do something different could give some unexpected results. But regardless, for a teaching concept, it does work. And then here we finally get down to the eval-based approach. And we can see that we are defining the metaprogramming as a string. I actually thought this was something special that I'd never seen before, but then when I read on, and he gives a heads up that there's a explanation coming. When I scrolled down here, I saw that we were actually appending to an array. So we're evaluating this apparently on an instance of array, I think, unless I'm mistaken there. And then that's why the appending is actually sticking it in this array. And then we're just joining all those strings together to pass something to the Ruby runtime to actually compile the Ruby code down and turn it into methods. The author does mention at some point here, there's only one good reason, and that is performance. This was the only reason I could think of why you would do that. I did take a note that he mentions a bunch of reasons why it is more efficient to use or more performant to use eval with a string. One that he didn't mention that we talked about in the previous book. Well, we didn't specifically talk about it in regards to metaprogramming, but we did learn in the previous book that if you store a block, which happens in some of this metaprogramming, well, here we're passing around a block with I assume that this becomes a closure because we have a handle on it. And we learned in the last book that a block gets moved from the stack to the heap when it becomes a closure. And I wonder if it seems like that would play an additional role to the reduced performance on top of the examples the author gives, although I'm not 100% sure of it, just it feels that way. The author does give, he mentions a safety risk. So there's definitely a safety risk when you're, and everybody knows about this in all programming languages that allow evaluating a string, but there is a safety risk where it's like the SQL injection risk, where if you receive input from a user, you don't want to just execute it as privileged code as if it's safe, because it gives the user the power to do dangerous things.
I believe you're right, and I don't know where I read it. I think it might have been Polish Ruby, where so blocks are the only thing in Ruby that are not objects, and so before they can be used, blocks are converted into procs, and a proc is a closure. So
Yeah.
so yeah, you're right.
Okay. Yeah, so that getting back to the safety thing here, the author gives an example where we're validating that the method name matches something. He points out that these days any Unicode character is a valid character in a method name. I actually didn't know that. That kind of surprises me, but because that's the case, it makes it harder to write a true validation. But this is going to hit enough methods that we're basically validating that name is that it's safe to do this string evaluation because it matches this regular expression that guarantees that the user can't do something dangerous. And in the case where we can't guarantee it, we go ahead and fall back to the block-based approach. This is a technique for if you absolutely positively need the performance of a string-based eval, this is one way to at least do it safely in the situations where you can. I'm going to check my notes. One note I took is that I don't believe in my entire Ruby programming career, I don't believe I've ever done a string-based eval, not once. But I have seen it in a lot of code. One reason I personally avoid it that I don't think is mentioned in the book is that when something goes wrong in the method, when I go with the block-based approach, I get a more meaningful error and stack trace, whereas it's not great when you get like a line and then you follow that line in the stack trace and you see like a giant interpolated string. It's less useful. And sometimes if it's not done right, you don't even get that. So for debugging reasons alone, I wind up actually avoiding the string eval. It could be that it's much better today though, because that was like 20 years ago that I was having that experience. Maybe it's better. Regardless, I've never done a string-based eval, and the only reason I probably would do it is if I needed absolute performance, which it very rarely comes up in the Ruby code I write that I genuinely need the absolute most performance. Well, it's two things. Not only do I need the most performance, but I've already picked off all the low-hanging fruit of like caching and all this other stuff. And the only thing left is, changing from a block-based eval to a string-based eval. I just haven't personally worked on code like that. So,
But wouldn't that still be slower than writing C code and using FFI to call C code?
yeah, it would. So you could always get even more performant than this if you needed to. So that's true. If you could pull off, I guess it depends on specifically the problem you're working on. But yeah, like if you're like looping over stuff and doing a bunch of number crunching, you probably could get much better performance by switching to a C extension and now switching to a C extension, I think, has its own downsides, of course, but yeah, I think you could get even better performance than just switching from block-based to string-based eval in a lot of situations. That makes sense to me.
We have a new person. Welcome, Justin.
Oh, hey, Justin.
Hey, Justin.
What's up?
We're like about halfway through the chapter, but I don't know if you have any like thoughts or notes or whatever on the earlier parts of the chapter. I guess maybe when we get to the end, I think we'll get to the end pretty fast this time because I didn't feel like it was that long or dense of a chapter. That I think you can chime in with whatever thoughts you had. So yeah. Okay, so I'm just flipping through I'm going to check my notes to make sure I have nothing else to say on this section. So then the next section here, we are going to get into method missing use. He gives examples here of here's one type of metaprogramming where we are using method missing. The author is making an example here that we can't really predict what the person writing the code, we can't really predict which tokens they're going to put here. So the methods that could be called are pretty open-ended in this case. And so the author also goes to demonstrates here. I forgot what the author was doing here. We're calling method missing, we're calling define singleton method outside. Okay, so basic object. So I see what's happening here. We're creating a basic object. Now the reason we're doing this is because object has a lot more methods on it than basic object does. If you actually look at basic object, I think it only has like about 5 or 6 methods on it, whereas object has a whole ton of methods. We're just using basic object to increase the number of valid tokens that could be accepted here. Because basic object doesn't have kernel mixed into it, but we do want to call define singleton method. The author is doing it this way. I'm pretty sure that when I do this, I actually tend to inherit from basic object when I write this type of code personally. But I also feel like in this case, because we're dealing with a specific object, I might even be able to get away with class less than self. Long story short, even though I have made use of basic object, I've never actually done it this way. So this is a new way to do it that I had never seen before. Working with basic object, by the way, is really annoying in my opinion, because when you stop on a break, it's like even hard to just stop on a breakpoint in the basic object. So one thing I do in my code sometimes is when I'm debugging it, while I'm debugging it, I'll actually change this to object from basic object just so that I have access to all the methods that I'm going to need in order to debug the problem. So basic object can be pretty annoying to work with in metaprogramming for that reason. That's not really what the author is getting at here, though. I should get back on topic.
I think you might be the only one of us that has done extensive metaprogramming like this.
I see. Got it. Yeah. So the reason why I would want to use method missing in this way is actually to build a DSL. And that's something that I have done. And there's different ways to build DSLs, but if you build a DSL where methods are the approach to expressing the concept, then you wind up needing to use method missing because you have absolutely no clue which method the author is going to call to express their thoughts. And so this is something that has come up for me. So I guess I should kind of skim along here because this might not be as interesting, but here basically we have this words, it accepts a block. We're creating, so here we're actually inheriting from basic objects. So this is closer to what I would do. So I guess I should reread the text here, but I don't do this approach. I would do something a little closer to this approach. And now we're defining the method in here. Looks like we're building up an array. So every single time one of these methods gets called, none of these exist as methods on the current object. So they're all going to call method missing, which we've defined to just append to this array. And then it looks like we reverse them for some reason that I don't recall. So here we have struct 50. Let's see. Okay, so this is actually, we're moving on to a different example. Here the author, and I'm wondering if I've ever you know what's weird is I've violated this before, and I actually must have taken a note on it. Yeah. So basically, if we're in a situation, so here what we are actually trying to do is we're really just trying to delegate from one object to another. So we're trying to delegate from an instance of struct 50 to this fields. Let's see. What are we delegating to? To this fields attribute accessor. So basically, we have this attribute accessor, which is in a hash, and we're kind of, our struct 50 class is operating as a proxy to this hash. There's two ways we could do it. One is we could just do method missing. The other is we could actually iterate over all the valid fields and explicitly define methods. There's two reasons why I wouldn't do this. One would be if I can't predict what the valid fields are going to be, then obviously it becomes more like this use case up here where we just can't predict it. The other use case is if it's just an overwhelming number of fields, which then I think the author later on mentions that that's actually okay. And again, I don't remember where that is in here, but somewhere in here he mentions if there's a ton. Oh, here we go, over 1,000. That being when you have a very large number of valid methods, say 10,000. My cutoff is probably actually more like 100, maybe 1,000. The author understands Ruby performance extremely well, so it could be that 1,000 is probably a better estimate than my intuition, which would be 1,000. But anyway, I actually would be doing this more for my own convenience than concerns about performance. I'm kind of moving along here pretty quickly. I think the key thing to point out here is that I think what the author is really trying to point out is that if you have a choice between a block-based approach and a method missing approach, you should go with the block-based approach unless a very specific set of criteria are met. That criteria being, most of all, that you just have no predictable way of knowing what the valid types of expression actually are. And then the author also makes an exception for when the number of when the number of blocks you would be creating to pull off the metaprogramming is around over 1,000. So they have a cutoff. So if method missing prevents you from creating 1,000 blocks, then it becomes okay to go with method missing. Is the author's stance here. I think the author points out a couple other things, which I don't remember exactly where, but I think he mentions that method missing becomes more difficult to debug than a block-based approach. And I think he also mentions that when you go with this block-based approach, if you do any kind of introspection on the object, you'll actually see the method names. Whereas if you go with this approach, you can't see the method names because they don't exist. And that would be one caveat to consider once you're over 1,000, you would have to say, the performance boost is worth not being able to ask the object what methods it can respond to and getting a meaningful, a correct, accurate answer. And yeah, that brings us to the end of the chapter. I'll check my notes because I might have some things I didn't mention.
Well, so the list of methods is stored in is stored in an array, right? So when you're searching for a method, it has to iterate through the entire list, and I suppose that's why. Um, I mean, I don't know why the number 1,000 is magical, but um,
Yeah, I think the number 1000 is magical because in this approach, you're creating one method. And in this approach, you're creating 1,000 proc objects. So putting 1,000 proc objects in the heap versus putting 0 proc objects in the heap is the
yeah.
difference. Yeah, or at least I think that's what the author is getting at for the most part. Um, the other thing is that when you do hit method missing, I think you do have to search. Although I think Ruby caches this internally, it's weird because when it comes to performance, whatever kind of magic is in the implementation can like completely invalidate a claim. But when you are calling a method that doesn't exist, you have to check the method dictionary of every single class. You have to look in the class of the object, and then you have to follow the super pointers all the way until you hit the end, which is going to be basic object, is going to be at the very end of a potentially long chain.
Hmm.
And then you have to call method missing on the object. So it could also be that method missing might be less efficient as well, just because it's going to take you have to get a bunch of method dictionary misses before you finally decide to call method missing. I think in reality, this is actually cached in the object somehow, and it might actually be able to figure out really quickly without following any pointers that it needs to call method missing. But I actually don't know if that's true or not.
No, we
I
did
really
read
don't
about
know.
the caching, like
Yeah,
but it gets cleared every time you define a method.
yeah,
So every time you call define method, it clears the cache.
that makes sense. Yeah. Cool. So that is the end of the chapter. I don't see anything else interesting in my notes to call out. I don't know if anyone had any other uh, thoughts or conversation or discussion or whatever around these types of concepts. Um, I could
No, I
show
mean
just I could just for fun show basic object. Let's just do if I do like basic object dot new dot methods.
no, it
Oh,
doesn't have
oh, that's
methods.
funny. It doesn't even have
You can't
methods.
even count that way.
Yeah, you can't even count them. What I could do is I could do instance methods on the base class. Methods. This should work. So these are the only methods a basic object would have. Whereas if I do object.instance methods, and I'll just put size here, there's 60 of them. So what is this? This is like about 8 of them. So basically, by using basic object instead of object, the author is freeing up about 50 some odd additional tokens that the user is allowed to use. And so I think that's why the author chose basic object in that situation. So I can't think of anything else to add personally. I don't know if Samuel or Justin, I don't know if Justin is still in the, I guess Justin had to drop off. So yeah, I don't know if Samuel or Nelson, if you guys have anything else to add.
I'll just say that a lot of
Uh-huh.
the content in this chapter was new to me, and so it was a slow read because I
Hmm.
really had to go through and try to parse the code because it was very like I haven't encountered this much.
Yeah, that makes sense. And you would hope that most people wouldn't have, like most people need to be able to write their Ruby code with a simpler mental model. And actually that kind of demonstrates the double-edged sword. Because like if you haven't seen this stuff multiple times and there's a bug in the meta programming, it really is annoying to try to solve the problem.
Right.
Um,
And especially if
yeah,
they don't know the tricks like changing basic object to object, like,
yeah,
oh, wait, I can't even debug this. I don't know what's
yeah.
going wrong. There's a bug, and I don't even know how to debug it.
Yeah, I like to use, I've been using binding.pry. Interestingly, the author of the book, I think, uses binding.break, which ships with MRI, which I've never tried. I should try it. But yeah, if you like run into it, you're like, oh, there's a bug here. I'll type binding.pry and you get a no method error on binding. You're like, oh no, what am I going to do?
I've been using binding.break just because of the syntax highlighting.
I have never used it, so I'm going to take a to-do item to try it and see if I like it. Because I actually like the proposition of potentially eliminating a dependency from my project. So
I think that was why I started using binding up break as well, because I didn't have to use pry. I think I don't quite remember, but these days I just use debugger, like debugger in my code instead of like binding anything. I don't know if that works in Ruby or if it's a Rails thing.
I don't know. I do know I have two ways of debugging. The first approach I use is usually binding.pry, and if that's not giving me good results, I switch to the debugger in RubyMine, which I think is called dbase, like DEBASE. I'm not 100% sure. I think that might be its name. One thing that's awesome about that debugger that I really like that I don't like about binding.pry is that when I'm on binding.pry, it always steps into the next method that would be called. But when I use dbase in the IDE, I can actually click on which method I want to step into, which saves me a lot of time because sometimes it steps into the wrong method. I have to climb all the way out, step into the wrong method, come out, and then finally I step into the right method. I don't know if you guys know what I'm trying to say, but yeah.
I don't think I've used. No, I've not used the debugger in like the JetBrains IDE or RubyMine. I just write debugger like instead of writing binding dot pry or dot break, I write debugger instead.
I think
And
it's
I can
just
try
an
that.
alias. That's just an
And
alias for binding.break.
yes, I think so. So
Oh, okay.
I'm not sure why I started using that, but I know early on I used to use binding dot pry, then dot break, and now it's just debugger.
There's another reason I use dbase in RubyMine occasionally. If I'm debugging something where there's like 200 stack frames and I genuinely have no clue where the problem is, in binding.pry with pry bybug, I can just type up 200 times to check them all. But in RubyMine, I can actually scroll through the whole list of stack frames and click on whichever one looks interesting to me. So those are the two reasons I switch from my default is binding.pry because I'm usually running the code in a REPL and it's just easier for me to stay in the terminal and hit the breakpoint. But if it really is something sophisticated, I'll actually switch over to dbase. Yeah.
I see. I tried something one time. It was kind of silly. So it was with the Ruby Money Gem, but I used it in Rails. And so I wanted to know at what point in the instance or like what in the object creation that it filled filled the other attributes. So for example, in the DB, if you add the money like capabilities to a class or to a model, what we're adding to the table is like amount cents and amount currency, something like that. So, but it creates this amount method that is not on the DB. It creates that on the fly for that model, like the instances and all, and it does some cool stuff. So I wanted to know at what point does it create that, and so I tried to read the source code, but it was hard for me to find like where exactly it was doing that. So I decided to use a breakpoint that's like binding the break or something like that. And so I kept going for so long, for like 30 minutes. I was just going next, and I gave up eventually because it seemed like it was endless. Because the next frame would be something about like active record, and it's just so much interaction there. I was surprised that there were so many calls between like model.new or create and like getting the actual model. It was crazy. It was such a brute force method. I wanted to, with each step, I wanted to see if that attribute already existed. And so I would step once, check, okay, not yet, step again. One time I started stepping like step 10, step 20 or something like that. And I don't know, it was just kind of silly. I gave up on that really
One
quickly.
thing, I'm assuming you must have done something like this or whatever, but and I don't know if this will work for your specification situation, but I would normally wrap binding.pry or binding.break with an if statement, like if this value is this, then hit the breakpoint. You know what I mean? And
Yeah.
sometimes I actually use global variables for. I don't like commit. I don't like use the. I don't actually check in the global variables, but just for debugging. Sometimes I'll set a global variable to true in one part of the code, and then elsewhere in the code, I'll say if this local variable, then binding.break, so that I can allow the program to just run until the break condition has been met, and then actually only break if this only break when the system's actually in the state I'm interested in, kind of a thing.
Ah, interesting. Maybe something that could have worked for me. Maybe the condition would have been if a certain attribute existed on the object. I'm not sure, but I feel like that could have made it a lot easier because I gave up without even finding out at what point. So I might try that again some
Yeah,
other time.
another technique is one thing that can be annoying about the approach I just mentioned is sometimes you need to break before the system enters a bad state because you're trying to figure out why did the system enter a bad state. And
Yeah.
sometimes you want to actually break before that. So what I'll do is I'll get on a breakpoint once the system is in a bad state. I'll try to climb up the stack and put like a put S somewhere that prints out something meaningful about what the program is doing. I'll then run it again. I'll see the last line before the system entered a bad state. And then I'll put a break in that checks that condition, if that makes sense. Um,
Mm,
and sometimes that's like the only hope I have of being able to like understand why the system is failing. Um,
I see.
Yeah.
In,
S-
in my case, oh sorry,
Yeah.
go on, Nessa.
So yeah, I mean, what I've done is you use that conditional, right? Like if this is nil, like whatever, a break if this is nil, right? But right above that, you print to the console all the previous information. So in your console, you get a whole list of all the things that worked fine, and then you break on the nil, and so you read right above it, well, what was the value right before this break, and your print statements will tell you, oh, this was some value right before. So I've done that when I was parsing CSVs, and for some reason I was getting errors, and it turned out that so there was uh, malformed CSVs somewhere that I was parsing wrong. So I was able to get the row that way of the CSV, and I could then take a look and see, oh yeah, this is why. Um,
Oh, so were you manually printing those things out to the console, or how are you doing that?
yeah, I was manually printing out to the console. So I would put a print statement, and then right below the print statement, it would be the conditional statement for when to fire the debugger, like binding.break if this value is nil, and it would get to that nil condition, and then I would read all the previous print statements and see, okay, why is this nil on this line?
Ah, I see. So I don't know. In my case, there was no breaking code. I am not quite. I don't quite remember what exactly I was trying to do, but I wanted to. I had say I had like loans and payments, for example, and I wanted to. I think if I'm remembering correctly, that I wanted the payments to sort of inherit some attributes from their loans while the payment is being created. So something like say the loan is in USD, I don't want to have to specify the like the currency for the payment. So I wanted the payment to read that from the loan before it was created, and get that. So I was having issues with doing that, getting that to work. So I wanted to read like, oh, how does this gem work then? I thought this would work, right? So I went to read the source code, like at what point does this thing exist on the loan? Because all the points where I thought it would exist before creating the payment, it didn't exist. I couldn't read that value, right? So I feel like it would require a different approach. Eventually, I found something much simpler. I didn't have to do any sort of like callback thing, but I feel like it would require a different approach because I can't exactly put a print statement in the library code.
You can though.
Yeah, you can. I do that a lot. I do that
So
pretty often.
Oh, I can.
yeah. So
Yeah.
if you do a bundle open and then the name of the gem, it'll open up the gem, and then in that gem you can start to put in break statements.
Oh, wait. I think Ruby Mine lets me add my own code. I just never did that really. So are you when you're doing that, are you doing that at the location of the gems install? Are you
I
working
do
with
it.
like gem directly, like the
Yeah,
source
I do
code?
it one of two ways. One way I do it is I just really lazily edit it on disk wherever it is because I didn't know about the open concept that Nelson just mentioned. Although I'm guessing that edits it in place where it's installed. But what I do is I edit it in place where it's installed, and then because I'm scared of that I didn't restore it back to its original state, I'll actually delete all my gems and rebundle once I'm done. Once I'm done debugging, I basically just delete all the gems and rebundle. The other way I do it is sometimes what I'll do is I'll add it to my gem file with a either a path or a GitHub keyword, and it'll actually check out the. You can actually like tell Ruby gems in your gem file use the gem from GitHub. Don't use it from rubygems.org.
Yeah.
And you can like vendor the gems and have your own local copy. So one thing I'll do sometimes is I'll actually clone the gem locally and then point my gem file using the path keyword to the
Uh,
local copy of the gem. The reason I do that though is not to have to mess up my um, I do that because then RubyMine will actually index that project. And that makes it easier for me to navigate the code in that project. It's not as easy to jump around. You can still kind of jump around in your like the gems that you have installed in RubyMine, but it works a little bit better if it thinks it's just yet another one of your projects. So yeah,
uh,
I've done multiple approaches, but the first thing I do is I'll usually just edit the gem on disk usually through RubyMine, and then if I don't remember to fix the gem back to how it was before, I just delete the gems and reinstall them.
I see. I think that's what I was scared of because I saw that I could write to the gem, and I was like, dang, I hope I don't break something. So interesting. I feel like that would
You
have
know,
helped me a
if
lot actually.
if you do break the gem, bundle install dash dash re-download will erase what you have on disk and install it again fresh.
I see.
I didn't know that either. I didn't know that. That would definitely have saved me a little bit of time. So
Yeah, and the reason I suggested bundle open, and using RubyMine, you probably get to the right version of the gem that you're using. But usually I'm on NeoVim and in a terminal, so I don't have RubyMine. So bundle open, and then the name of the gem will look at for the correct version of that gem on disk, because you might have different versions if you're using that gem in different projects, and they have different version numbers depending on the project you're using. So bundle open, and then the name of the gem will get you to the right place based on the version that's installed in your gem file. .lock.
yeah, Yeah, RubyMine does jump you to, you can, like, it'll jump you to the right version. And you can see all the other versions like right next to it, but it does do a good job of taking you to the right one. So yeah.
Yeah, I see. I would I think I had a similar experience reading this chapter as Nelson. Um, so I've seen a lot of these methods before, but I've not used them as much myself. So I always forget what exactly one of these things do, and so I just like oh, sorry, one of these things does, and I just have to search it a lot of the time, look it up, and it makes the reading slow because I stop here and like, wait, what does this one do again? And I'm like, I see, okay, and continue. So I plan to come back to this chapter and just slowly read it and pick up on things.
Yeah,
Maybe,
when I have to define something like respond to missing, I often forget its interface, so I have to go look it up anyway. There's like a Boolean value, and I don't remember what the Boolean value represents. So I think like having to go look up what the method does is just kind of a natural part of programming, like anyway. Like you never fully get away from having to occasionally look up what a method does, or exactly what its interface is, or exactly what the scenario is where you need to use it. Uh, I think the author mentions respond to missing in the chapter very briefly, but it is important to define that method. And I always forget exactly what its arguments are and stuff.
yeah, the opposite then.
You know, I don't use AI for everything, but the like I just and I didn't use it for reading this chapter, but I just thought that like, oh, you know what, if I am ever confused about what a code snippet does, like AI is pretty good about explaining line by line what's going on in some piece of code.
Yeah, that's been my experience as well. Especially like SQL, anything really. I'm like, wait, what does this SQL query do? And it just tells me the part that, and I can ask like the part that confuses me, and then
Yeah,
I
it's
have to
definitely
like,
helpful. Yeah,
of
I,
course,
I use that too. Oh, sorry, I didn't mean to interrupt.
sorry,
Oh,
you
I
have
was
that.
just I
Mhm.
was just gonna say it sometimes like flat out lies, but lies confidently, and that probably only it depends on what you're asking it about the code. But
Yeah,
I just wish that when it didn't have a good solid answer for good reasons, it would just be like, I'm actually not sure. But since it, instead of saying I'm actually not sure, it just makes something up. Uh, and this only happens maybe like 1 out of every 20 times, or maybe less.
yeah,
Um, it causes me to sometimes, I definitely ask it, I love asking it things where I'm familiar with the concept. So if it's wrong, I'm gonna know. Um,
exactly. Yeah.
so actually respond to missing would probably be a good one. Although it could get that wrong too, actually. That would be another one where I'm kind of mildly scared to ask it. At least it's a public method, so it's very likely to be well trained on it. Um, but
Yeah,
yeah, it's sort of a
yeah.
double-edged sword. I
Just
wonder if it'll get better. I wonder if it'll get better, in the future. If it could just tell me when it doesn't know, I'd be so happy.
I think he doesn't know anything, so I'm not sure that that's gonna like it just tells you what is the most likely thing, and so like whether it's wrong or not, it doesn't have that concept really.
Yeah, I guess so. I don't
Or,
really know because the whole thing is such like a black box to me that I just don't know what it's doing really.
yeah,
By the
I
way,
remember.
I don't, this is off topic, but I learned something interesting about a week ago. So one thing that has confused me for maybe like 4 or 5 months is like, why when I set the temperature to 0 is it still non-deterministic? And I figured it out. It's because this is something I never knew. So I always knew floating point numbers. You lose precision when you're doing arithmetic operations. So you have to be careful. So Samuel, you were mentioning doing financial programming. You have to kind of be careful, and people say never use floating point numbers with financial stuff, I don't think that's necessarily true. But if you don't know, you definitely shouldn't use the floating point number. Just depends on what you're doing. But by and large, I think everyone knows about the dangers of using arithmetic operations, especially for things like finance, with floating point numbers. What I didn't know is that floating point numbers do not have associativity over addition. So the order you add floating point numbers changes the outcome. And so what's happening inside the LLM is it's parallelizing a whole ton of additions of vectors that contain floating point numbers. And the order it adds those numbers in gives you a different result. And since that order itself is non-deterministic, the outcome is non-deterministic, even when you set the temperature to 0. So that's something I learned a week ago that I never knew about floating point numbers, but now I do.
Oh, interesting. Set the temperature where? Like
The way I use these APIs, I use Ollama, OpenAI, and Anthropic. I'm calling their APIs. I'm like writing code that's integrating an LLM. And when you make those API calls, you can set the temperature to 0. If you're referring to something like Claude Code, I'm sure there's a setting somewhere that you could set it to 0. Although some models don't accept, like I know O1 and O3 from OpenAI, they'll give you an error if you try to set the temperature to any. You can set the temperature to 1, which is as random as possible, but you can't set it to anything other than 1 or you get an error. And I have no clue why. But yeah, usually it's going to be some kind of a setting, or if you're using an API, it's going to be an input to that API. You can specify the temperature.
Oh wow, I didn't even know about temperatures with with these models.
Yeah. The more creativity you want, the higher you want the temperature, and the more consistency and determinism you want, then the lower you want the temperature. So if you're writing haikus, you would set the temperature to 1. But if you're like trying to make a financial decision on some inputs, which is pretty scary to do anyway with an LLM like that, then you would definitely set the temperature to 0, because you would, it's determinism versus non-determinism. That's definitely a use case where you want determinism if you can get it.
Yeah, that makes sense actually.
Yeah, that's
going
off
back
topic,
to just understanding the code in general, like when I don't know what a method does, I just go to the definition of that method, and for me it's just 2 keystrokes GD to go to the definition. So if I don't know what instance variable get is for instance, I go to the definition and it tells me sets the instance variable named by symbol, blah 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 blah. Does RubyMine have that ability to go to the definition of your?
Yeah, you just hold Control click, and that's usually how I get into the code in the gem in the first place. I just hold Control and click on the method, and it'll jump to it. Okay. Then if I start typing, it'll give me a warning that I'm trying to edit, a gem, and ask me if I want to proceed, and then I say yes, and then it'll actually let me edit the gem file on disk. But yeah, it's like Control click is how you jump to it.
Okay.
Sometimes that's good enough to help, and Ruby is actually a good language for that, because you can write self-documenting code. But sometimes you jump to the method and it's just delegating. It's basically delegating to another method, and you jump to that method, and it does a little tidbit of something you don't understand and delegates to some other method, and you wind up, you can wind up like through 50 layers of that sometimes, and those would be, and then if you're crossing metaprogramming boundaries, those are kind of the situations where, it won't be enough to just read the method. But yeah, sometimes it is. Sometimes you jump to the method and the method is like nice and clean and self-documenting, and you don't even read the code comment. Like you don't even read the code comment above the method. You just read the method and you get it. But yeah, sometimes it just kind of depends. Sometimes you jump to the method and it doesn't answer your question.
Yeah.
Which I'm assuming is your experience too.
Yeah, right. Working with videos, it's almost guaranteed that I wouldn't understand the method at first. I have to really